Hello everyone. Today we're going to look at what I think is the easiest Final 5 AMC 12A problem yet. This is the 2003 AMC 12A number 24. Okay, number 24. That means it is the second to last problem. And this, after you see this solution, you're going to realize this does not deserve to be number 24. But anyway, let's just solve this. So, if a is greater than or equal to b is greater than 1, what is the largest possible value of log a, base a of a divided by b plus log base b of b divided by a? So right away, when you see this largest possible value, you should immediately think of the AMGM inequality, because you might be able to manipulate some type of expression to give you some large value. But first, let's do the obvious. Let's simplify this. So log base a of a divided by b is the same thing as log base a of a minus log base a of b. Those are just simple logarithm rules. And we can do the same thing for this one. So plus log base b of a minus, plus log base b of b minus log base b of a. Okay, log base a of a, log base b of b, those are both 1, because if the base and this number are the same, then the answer is always 1, because log base a of a is the same thing as saying a to the power of what equals a, and the answer is obviously 1. So you have 1 minus log base a of b plus 1 minus log base b of a. So we get 2 minus log base a of b minus log base b of a. Okay, and then we can factor out a minus sign, I guess. Log a of b minus plus log b of a. So there we have it. After simplifying, we get this. So we still have this expression right here that we need to evaluate. So in order to make this a maximum value, this expression that we're subtracting from 2 has to be the smallest, right? So at this point, we can use the AMGM inequality. Now I will make a video about that inequality really soon, but if you're impatient, obviously you can just search it up online. There's a bunch of stuff about it. But anyway, the AMGM inequality states that the arithmetic mean is always greater than or equal to the geometric mean of an expression. So let's take this expression and divide it into 2 terms. So obviously this is pretty easy. We got log base a of b and log base b of a, 2 different terms. So the arithmetic mean, log base a of b, and then the second term plus log base b of a is divided by 2. That's how you get the mean. You add the 2 terms up and divide by, 2. Don't know why I wrote a there. That's always greater than or equal to this right here. So the geometric mean, which is the square root of the product of the 2 numbers. So square root of log base a of b times log base b of a. And now we just have to use our knowledge of logarithms to see that log base a of b times log base b of a, if you switch the bases, because you can switch bases, keep in mind you can switch bases when logarithms are multiplied together, to log base b of b times log base a of a, you get the square root of 1. Then you multiply by 2 on both sides to get log base a of b plus log base b of a is always greater than or equal to 2 times 1, 2. So we see that the minimum value that log base a of b plus log base b of a can be is 2. So we take that minimum value and we plug it in back here. So we get 2 minus log base a of b plus log base b of a, which is 2. And that equates to 0. So that is the answer to this equation. The largest possible value of log base a of a divided by b plus log base b of b divided by a is 0. Now, once again, I am not sure why this is number 24 on the AMC 12A. This is a 3 to 4 step problem, and if you are experienced in the AMC 12A and you are tackling the final five in the actual test, then this should be a piece of cake for you, because you've done much more difficult problems than this, so this is pretty much a cakewalk. But whatever. It's the judge's idea, the test maker's idea. See you next time.